David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Today's topic, union and intersection. These are two ways that sets can interact with each other. So we're going to talk about what these two terms mean, then we're going to throw up some Venn diagrams and some examples to show how that works. So, first off, here's a little bit of notation. If A and B are sets, A intersects B is written this way. This little symbol, the upside down U, means intersection. So the intersection of A and B contains only elements in both sets. So we've already looked at this in a couple problems here and there. So this idea shouldn't be new to you. The second idea is when you turn this back to being a regular U, this is the union of A and B. As you might think, the union is just putting all the elements together. So the union of A and B contains elements in both sets. Okay, let's show that same idea, that concept, with a couple Venn diagrams. We won't have any numbers on these, but it's a good starting point. So the intersection of A and B, if we draw our basic Venn diagram, rectangle, intersection, so there's our intersection. Here's the universal set, A and B. So the intersection is this area here. So that's the intersection. So all elements that are in both A and B. Now the union is a little bit different. Okay, same thing as before, two sets. They do have an intersection, but as you recall from the definition on the last board, the union is the elements in all A and B, in both sets. So now we're going to shade the entire pair of circles, like that. So this is the union. Okay, let's do a more involved example that puts all this stuff together in one set type problem. So what we've got here is we've got this universal set, we have a set A, and we have a set B. And we're going to talk about their intersections, we're going to talk about their unions, we're going to talk about complements, we're going to do the whole thing that we do. So, first off, U, our universal set for this problem, is a set of all x such that x is less than or equal to 12, and x is an element from the positive integers. So another way to say that is, our universal set is all the positive integers less than or equal to 12. Let's write that down just to make sure that we've got it. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's our biggest set. So everything in this problem relates to the numbers that are in that set. Okay, set A is primes less than or equal to 12. So all the prime numbers that are in this that are less than or equal to 12. So what we get is, 1's not prime, remember that, 2, 3, 5, 7, and 11. All the other numbers that are in this universal set are composites. They can be factored into smaller primes. Now, B is the factors of 12. So these are all the numbers that can be multiplied together that can make 12. So those numbers are 1, 2, 3, 4, 6, and 12. Because 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. So these are all the factors of 12. Okay, so now our stage is set. We have our universal set, we have it described and shown, we have our set A described and shown, and set B described and shown. So now we can take a look at our Venn diagram, which I've conveniently labeled for you. Here's our A, here's our B, and here's our U. And we can start throwing these numbers on there. Now, if you remember from the last example, when you fill in a Venn, it's sometimes easiest to work from the inside out. So that's this area here. This is the intersection of both A and B. So what numbers are in both A and B? And we see we have a 2 and a 3. Those are the only two numbers that are in both sets. So we write 2 there and 3 there. Now, what's in A that we haven't already put in the middle? So I've got my 5, my 7, and my 11. So that's 5, 7, and 11. They're not in B, so they're not in the intersection. They're actually in the A only part of A's circle. Okay? Now let's do the same for B. The 2 and 3 are already taken care of, so that's going to leave the 1, the 4, the 6, and the 12. Those are the ones that are in B but not in the intersection. And now don't stop here. There's one more step. You've got to put all the other numbers that aren't in A or B, and they need to go in here because they are part of the universal set. Remember, the whole rectangle is the universal set. So let's just go through it. 1, we've got 2, we've got 3, we've got 4, we've got 5, we've got 6 is there, 7 is there, 8. 8 is not in A or B, so 8 comes out here. 9 also is not in A or B, so we've got a 9 out there. 10, I don't see 10 in there, so we've got our 10. 11 is here, and then 12 is there. So 8, 9, and 10 are the three numbers that are in U, not in A, not in B, so they go out here. So that's our Venn diagram. Our sets are described. Now we're ready to answer some questions. Okay, I added a couple things. List the elements of the union of A and B and the intersection of A and B. Remember, the intersection is the upside down U and the union is the right side up U. Pretty easy to remember, I think. This also looks like an N for intersection. Okay, so the union of A and B is just all of these numbers. So we've got 1, 2, 3, 4, 5, 6, 7, no 8, 9, or 10, 11, and 12. So that's the union of those two sets, and the union will always be a bigger set than either of the two because it has all of them put together. Now the intersection is just the numbers that are in both sets. So here, the intersection is just 2 and 3. Okay. So that's an example of the first types of questions you'll get in these problems. Okay, one last set of questions. Again, having all this up is going to really help us answer these. Okay? So if you recall from your notation, this line asks the question, what is the number of elements in the union of A and B? So that just wants us to know how many things are in all of those two sets put together, their union. And that would just be all the numbers that are either in the A circle or the B circle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 there. Now this question is saying, what is the number of elements in the intersection of those two sets? So the intersection is just this area where the two circles intersect, and I've got 2 elements there, so that's 2. Now it wants to know, what is the number of elements in the complement of B? That's B prime. A little bit more tricky. Pause the video, see if you can dig into your understanding of what complements are, and see if you can figure out what that number is. Okay, let's take a look. Let's review what complements are. The complement of B, which is given here by B prime, is all the elements in the universal set that aren't in set B. Okay? So it's everything in U that's not in B. And so we can count those up on our Venn diagram pretty simply. It's 1, 2, 3. These are definitely not in B. 4, 5, 6. These are the set elements for A that are not in B. So we have 6 in the complement of B. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.